Okay. Excuse me. So, okay, you can see the whole screen there. So let's talk about, okay, yesterday we had a look at the software, and the software is actually looking very simple because you will be creating the operator. Under the operator, you will create the field. And after the field, you have facility. Facility could be structure. It could be the rig, basically the platform. Most of these very, very expensive wells are drilled offshore, basically, because offshore wells, you can also choose the locations. And things are very, very expensive. $50 million or something, $100 million and stuff like that are quite common in these, ERD type wells. So what do you actually need? What do you need for this to work nicely? You should be prepared for putting in the correct information, which I have mentioned. Even the software is quite easy to use, very, very easy to use. You could do it in few clicks. You may end up with an ERD profile or the well plan. So what you want to do at the start of the journey is to get the correct setup details. Setup details should include the coordinate system, references. You may or may not have surface location. Sometime in the early stages of the planning, you don't have a surface location. You find the surface location, basically. They will just give you the target, and then you go from the target backwards and following it from the reservoir, going backward to the landing point and the curve, and then you find out from where you can drill this well. And after that, people will do the kind of survey and everything and find out if this surface location is good or not good. So it depends upon the stage of the project. Most of the time, ERD wells, people have already done the homework. They have set up in their geological models and the places where they should be drilling from. They have a feel for surface location. So you may have more than one location. They will give you the choice of this location, A, B, and C, or something like that. And you can use those. So you need to have information about the coordinate system, expected surface location. If it's a platform, existing platform, which has drill wells in the past, you already know the location. Same with the rigs as well, by the way. If you have the rig sitting in there, they're drilling back-to-back wells. They already have got somewhat exact location for that. And the most important thing you need to know is the target. What are the prized reservoir locations? And those locations are given to you by the subsurface team. The whole idea of drilling these complex wells is to hit the targets, get to the right places downhole in the subsurface environment. So you have a kind of list of the targets. They will say, give me this target 1 and 2. For ERD well, you could also create your own targets. You can say, I want to kick off at this depth because of this formation allow you to easily kick off. And you create, say, okay, I will build to this target. You create your own well planning target. There are two types of target. One is created by yourself just to make your planning easier. Say you want to build to this TVD and that is the target. At this TVD, at this location, you created a target to keep you in the kind of nice setup. And those experienced well planners, they create their own targets. They call them something that is not official name. It could be just formation 1 target or formation 2 target, something like that. The geologists give you the target that you must hit. You cannot ignore it because that's the whole idea of drilling the well. So most important for you to confirm the targets are correct and also ask them the question, can I move this target left or right, up or down? What is allowed for me? Is this target fixed or can I move it? Why? Because sometimes your ERD becomes very, very complex. You want to have flexibility of hitting those targets. If you have, let's say, 50 feet thick formation, and that is your target, you created a rectangle of this thickness. This is your target. And you may be okay if you drill, if you hit the target not in the middle, maybe 10 feet below, because it's thick enough just in case you might need to go this route. So it's good to know. Also, the offset well. A lot of these places where you are drilling the ERD wells, there may be some other ERD wells. If you don't have offset well in the system, you may accidentally hit them. So very much common sense approach here. And just going about the planning is okay, very nice. You would like it. But be aware of these things that you have offset well. Do you have a offset well in your database? You need to import them if you don't have it in the system. Not just import them, verify the locations, verify the positional uncertainties. It's a complex discipline to have everything correctly included in your software, because the software is as smart as you are. You can work with the software and come out with result A. Somebody with a whole lot of experience will come out with some other results using the same data, using the same setup data, same targets. They will make this a directional well plan to be as close to reality as possible, because all these plan that you do, you have a draft plan first. At the very start of the journey, you have the draft plan. Draft is just a line in the sand. You will change it. Somebody will say, okay, change the target. Early days of planning. In the early days of planning, you have look-see plans. Look-see plans are just trial and error. Which one is the, so very first plan will be look-see one. Then somebody said, okay, move this, move that, change these places and make this look-see two then. And there will be some more shifts and bends. Somebody say, look, C3. And after a long while, everybody agrees on the plan. A lot of people say, okay, this could be our principal plan, principle. And then you can say, okay, let's make it a principal plan. Principal plan means this is the plan that had been gone through, that has gone through all the checks and balances. This is nearly perfect plan. It's still not ready to drill, but it's the one. Principal plan is usually the final plan if nothing else changes. If nothing else changes, you will call it Rev A, Rev B, Rev C. Now you upgrade the plan from look-see to Rev A, Rev B, Rev C. Similarly, at one point, people sign off. People say, okay, this Rev H or whatever, is the one that everybody agrees, no more changes allowed. We have done all the changes. For playing around, look-see. For real business, doing engineering and analysis, Rev A, B, C, D, depending upon changing shapes and sizes of these things. And final plan will be your next gate of drilling project management. So you have gates, yes. One is let's say pre-planning phase or early planning phase. You have look-see directional well plans. Second one is the kind of selection phase, or you are going through iterations. Then Rev A, B, C, D's. Those will come into the picture. And the last one is, okay, I agreed on last one. Let's define it. Define means define phase or detailed analysis phase in the drilling project management. You will sit down with the plan, do all kind of analyses on it, very detailed analyses, casing wear and everything, what kind of mud and all the stuff. So that is the principal plan. The very last plan is the principal plan. To get there, if you started with some ambiguity, if you start with some wrong stuff, everything that you have done will be wrong. Especially think about a simple thing like offset well. You put in offset well, you did not take a good care of it. Offset wells are not there they are actually in some other places. You find out because we did not incorporate them correctly and verify them. You can hit those offset well accidentally. You don't want to be in that situation. People can get fired. I have seen people getting fired for these things. Target, they give you a target, they revise the target, and you forgot about revised target. You still have old targets. And when you create the principal plan, the final plan, you have the wrong targets because you missed it, because they repeated the target, they changed the target so many times, you forget. And you did not keep track of which target is the latest. If you create this kind of trajectory with wrong target, you can get fired. If they drill the well, the whole cost of 60-80 million will be on your shoulder. Nobody does it, of course, because a lot of people look at it and they know it's wrong. But yes, that's a very bad stuff. Same with the surface locations. If you have wrong surface location, wrong elevation, this is the references. What references mean is the elevation from where you will be measuring your directional trajectory. Super critical. I have seen people drilling horizontal well. They could not find the reservoir because they have this elevations reference of the from where you are measuring the survey is wrong by mistake, few meters, because horizontal well, few meters is a big thing. So it's a very, very powerful thing. If you are not into the checks and balances, doing the meticulous review of everything, you should not be doing this work, because this work requires boring stuff, getting the numbers right from the very start. Okay, so this is just a word of advice because I have done this for quite a while. This what differentiates anybody who can do this plan or someone who can actually make this plan a success. When you show your work, you should be uh, relaxing, not worrying about that you will have big problems. So be aware of these inputs, correct inputs that you have references for, and how would you actually ensure that these are correct? You have a sign off. You receive information from the customer or someone who wants to do this, your manager, whoever, keep track of these emails. Write it down into the QA QC forms. There are QA QC forms available. If you don't have it, ask me, I will provide. That way, with dates and everything, people sign off that, is this the final target? Somebody will say, yes, you have an email to back it up. Offset well, ask them for the top and bottom lines of the offset wells, the whole surveys, and make sure yours matches with those. And you get it as sign off. Say, okay, you told me we got 10 offset well, give me the surveys, and then you created them in your system. Then you have a database similar to those, the same as the other person. And then you match them, sign off. Similarly, in the early days, you would not need casing program. You don't need formation depths. You may need some targets, but it's nice to have things like a roughly estimated where you want to set the casing, because you want to decorate even the look-see plan should be very close to your rev, and rev plan should be very nicely, kind of done, because it's not a child play or anything like that. It needs to be done in a proper fashion so that you don't have to worry about things later. Okay, so just a word about checks and balances. We are all engineers here. We don't have to reinforce too much because this comes with the job. Okay, now if I click some more stuff, details, what details we are talking about, getting it right. These are the details, north reference and things. Each of them have their own use. And then you can also do semantic collision things in the software if you have the good offsets. Okay, so let's come back to what you should do. As I mentioned, verify. And also you will be creating the kickoffs, curves and bands. You say kickoff here, give me the dog leg of this 3 degrees and 3.5 degrees, whatever you have in your mind. You just cannot come out with 3 degrees. In some places, 3-degree dogleg is big deal. You should know if they had problem getting the 3-degree built. Then you say, okay, I will not put 3-degree. What they were easily able to build with 2.5 degrees, 2 degrees, 1.5 degrees, whatever those are. You need to know what you can actually include in your plan. Can you build with that dogleg that they are asking from offset analysis, previous well drill in the same formations? You need to find out your, let's say, the field knowledge. This is what it's referring to here. Obtain information on previously drilled wells. You are looking to see how easy were they to drill, which formation imposed what issues. Okay. So let's get ourselves started, because we were doing something, when we left last time, we were into the software. Okay, so let me share the screen, and I'm hoping that you can see my screen just now. Can someone please say, Nikhil, yourself?
Yes, sir, it's visible.
Okay, so perfect. Thank you very much. Okay, what we want to do now, let's do ERD well. Just do an ERD well together. For this one, I would like you to take your time, be very slow. I will be slow with you so you can actually do it. For those who have the software, downloaded and the licenses that we have provided them, PEA and myself have provided them licenses. We gave them yesterday, okay? Yesterday, we did not get to do too much of it because we wanted to learn the ropes. We want to learn the tricks first before we start to get into the driving seat. Okay, so now we will be building this ERD well from scratch. Just like you just received instructions. You received instruction from your customer, and we start to populate it. What I will do after we set it up, I will paste the instructions to you, and then you start to work with me on this one. And this is the kind of main point of this session, to get you to this point where you can actually play with the software and build something out of nothing. That nothing is just a list of instructions, information given to you. Okay, so please follow along. You click on the very top, right click on it, say you have your own operator. Give your first and last name, the initials maybe, NS for myself. Have a look at, okay, now you can put the logos. You can say, okay, this company has got this logo. So you upload the logos. We talked about these. You can have a look at this one later, because this is something that will probably you can find out. You can say, what anti-collision policy my company follow? That's the question you need to ask. And then directional drilling department or somebody from upstairs, they will tell you which one to pick. Usually default, these are the default. If you don't know, or you want to start it anyway, and we think about it later, start with default. All of these are standard. What you are looking at is standard. Okay, and have a look at this one. That's the very important point there. 2 or 3. Ask about this 3. This is the positional uncertainty. How much confidence do you have that you will hit the target at 2 sigma? There's a small details on it. You can have a look at it in the document somewhere in Innova's website. You can learn about each of every of these fields so you can make the smart decision. This is the overriding rules. You cannot mess this up, because this will be used in calculation of everything that you do downstairs under that operator. Okay, so this is what we have. And similarly, you have alert separation when the separation between the two wells become X 100 feet or whatever, you can have these. You can ask these to sit down with maybe directional drilling people, sit down with them, the coordinator or whoever. You need to fill this in with them. So you have the correct one. Okay. Yesterday we talked about that one, so I'm not going to take too much time. Say, okay, I give myself a name. There's no contact or whatever, So let's say apply. When you say apply, it creates. Okay. Okay. So let's see. Here, you can see on my left-hand side, I'm highlighting it. Now you want to create a field. Let's create a field. Call it North Sea somewhere, not central, North Sea, central block A, whatever you want to call it, Now it comes up with a mapping grid that is selected. So let's see what we have here. It's sitting in the France. So we need to correct it, yes. So we need to put in some numbers. We want to go to the North Sea, and the North Sea is, you can see where the North Sea is. North Sea is right here between the UK and Denmark. This whole thing is North Sea. You can see it. So you want this to be here. And now you need to start to populate. You need to ask them, what is the surface location? Because you have been given that information. You assume that you have got this information. I have got this information right here. So I'm going to use it starting from here. I am looking for WGS 84 UTM zone N as November. UTM zone 30 N. Okay. Which is taking me to, and this information is given to me already because this is the initial instruction, part of the initial instruction. This will probably be the good one. Let's say yes. Okay. Let's just double check it. WGS 84, UTM zone 30N. And now well-centered, we talked about that yesterday. We need to populate the latitude that surface location have been given to us. So we will be using that now, okay? For that one, let's put in latitude is given to us, 55, 49, and 12. And also remember the north. It is north. So I selected north, it's already north. And then you also been given the longitude. Okay. Okay, suppose this is the one and it's east. So it's already selected east, but I just calibrated that one. Okay, now see the gray part. You typed in this, it calculates the grid easting and grid northing. Okay, sometime you are given the grid. You are given the easting and northing, not latitude, not longitude. You can calculate one from each other. If you are given grid easting, this will come if you type in. For example, suppose I am given these. It automatically, suppose I am given this number, it automatically calculates the latitude. So you have been given one of them. Depending upon what you have been given, you can choose. The mistake that people do is this or that, this can take you to far places. You see that one? It's gone somewhere far, far away from where you should be. If you do mistake like these, there's no coming out from it. You're just a very, very silly thing to do. But of course, you will not do it because you guys are engineers. So remember this one, well-centered is your usual default. Sometimes they have too many wells. They want to reference it from facility center. They have a large platform, for example. They have a center of the platform. They want to reference it from the center. But usually, most of the time, it's here. So that's perfectly fine. So this is what you have done to create created the field, you put in the correct, you have a look at this map, you are happy with it, and you say apply. Okay, apply, close. Now you got a field. Now you want to drill, maybe create a facility or something, which could be a platform, which could be a rig. So when you say yes, let's say platform 1 or something, platform A. Suppose this is a platform. Very important, grid. Most of the time is grid. We talked about templates, so we can have a template for the platform if you like. Okay, and this is just one well, so we are not worried about template. Yesterday I showed you how to do them. There's no point wasting any more minutes on it, but you can create template for the whole platform. If you have a platform, usually platform come with 24 slots, 36 slots, even 42 slots. And a lot of them could be ERD wells. Some of them are already drilled. They are your offset wells. And that's the beauty of this software. And also in this software, Innova allows you to import offset well. You don't have to create them from scratch. If it's coming from some other leading software system, they can import it with one click or two clicks. So you don't have to worry about, doing a lot of work to move them into this. And everything will be correct. Positionally, they will be correct. So you don't have to worry about uh, manual work for that. So suppose this is a platform. Somebody would say, can we have slots in there? Yes, maybe you can. So let's say template. Okay. And just say this. Okay. Say apply, sorry, template. Okay, template A. And then you say, I want 36 because my platform is very big. I want it to have 36 slots, so you can have 36 slots. Okay. And you can just say, okay, I want to just maybe have, let's say 20, 20. Something like that. And you can have, yeah, if you remember, this could be the kind of thing that you can do. And all of these slots, you can drill from them. You can have all of them drilled. Just like yesterday I said to you. Okay, so just come out of it and come back here. We did not create template, but we can. When we create it, we can have 36 wells plan. Some of them will be ERD, some of them will be horizontal. We do all the work. And you can also do some costing based on it, which I can show you some of the tricks. You can do the field development planning like this. With the same software, you can do the field development planning. If you're a geologist or in the early stage of drilling, you can do a whole lot of work with this powerful software. And all the wells, all the tubes and casings and everything, how much money is going to cost and everything, you can do a lot of smart work just by using the software and, of course, some instructions, some background knowledge. This grid convergence is very, very important. It's positionally sensitive. If you change position, this will change. You do not want to have this wrong. That's why it's grayed out. It's grayed out because it automatically calculates and you use them for correction of your surveys. If you get this one wrong, that's a big problem. Okay. Um, let's say this is what you want. Everything is the same. Suppose you don't want, and just last check. Is it still there? Yes, everything is fine. Just check it before you apply. When you apply, it goes into the system. Say apply and then come out. This is your platform. Now out of this platform, create a new well. This well is the big name under which you will have designs, under which you will have the type of well. Okay, so insert new well. Right now it is asking you just the name of the well that you want to plan, or you want to be drilling. There are two types of well that system allows. Right now is asking you just a top level name. Say NSERD, that's the name of the well, out of whatever slot 2. If you want, if you have 36 slots, if you have 36 slots or whatever number of slots, you can give it a name. Okay, let's say slot 1 well, slot 1 iteration. This is the iteration you will be doing, or well plan, or ERD. You give it a name like this. Okay, you don't have to do it now because we just have a one well. Okay, so just ERD. Okay, first well. You can have a description if you like. Now here it is asking you where you are drilling from. What is the surface location? If you have so many slots, which I mentioned, you select that one and then you look for the slot. Okay, you don't have to worry about it now because there's no slot. If you have 36, you have 36 of them under the name. Then you select the slot to which you will apply these well. Okay. On the right-hand side, positional uncertainty. In the early days, in the old times, people go offshore. They say, I could be 5 feet left, 5 feet right. There is a lot of heave going. If you have floating rigs, then you may have uncertainty of a few feet or whatever. The location is ups and downs and it's not sure. You can have numbers for it. The same location shows up here, so I don't have to touch it. Factor, everything is grayed out. What is important here is it's asking you what kind of rig you will be drilling with. There are 3 different types of rigs, and you need to be super careful with how you want to set this up. Because if you mess up this one, everything will be wrong. Surveys and everything will be incorrect because this is the references we were talking about. You need to get the references right. For your case, you are a platform. Platform has got legs sitting on the seabed and it's elevated up. They have an air gap and they have water depth. And then they have a seabed. So it's offshore and you need to give them water depth. Okay. Suppose it's 200 feet water depth. Okay, I put 200 feet. And then what is the height of the platform from the mean sea level? This is what it is asking, air gap. Okay, so let's put in air gap, RTE, table elevation. Okay, just a name. It could be any name. You can have the rig name. Say rig name RTE. And then you say default, and you would like it to be 150. Suppose it's 150 above the water table. And now you need to tell him what it is. You say water 200. Have a look at this one now. Let's stop and think about it, what we have just done. You have the mud seabed. That's your mud line. And you have the water depth, 200 feet. You have the air gap. This air gap is this between the water and the drill floor. It's usually the drill floor, not the lower part of it, because they have different layers. RTE is rotary table elevation, where you have on the rig floor, they have a rotary table. On the rotary table, they have these kind of height, this height, not the bottom of it. It could be 10, 20 feet off. People ask for what is my air gap. People can give you different air gaps. For you as a planner, air gap is exactly from the top of MSL to the rotary table. For some people, if you ask maybe subsea engineer or other guys, they tell you the air gap is the bottom of this structure from there to the MSL. It could be off by 10, 20 feet. Nobody knows. So air gap has got slightly different definition. You need to find out which one you need, which I have mentioned to you, rotary table elevation. If you get this wrong, all your surveys and TVD surveys will be off by that much, 20 feet off, 15 feet off. So that's something that you do. You don't have to type in anything here. So there is a thing for jackups and platform. This applies what you are looking at. For subsea well, the most expensive wells is different. There are instructions for it. Of course, once we get a chance to have a look at it, I can show you some of the things you can do for. Similarly, with onshore well, they have a different game. It's got a ground level and other stuff that you need to get it right. And there are different type of rigs, different type of elevations, different type of location. So we need to spend time. Maybe we need to spend 15, 20 minutes for each type to learn about it. There's no shortcut for this one, because if you mess up this one, you should have a clear vision of what you will put in the software, because software is not better than us. We tell the software what to do, how to calculate. Software does its math, and you just driving it like a car, basically, turning and twisting, moving it in that direction. So you need to put in these conceptual thing right. Okay, say apply. Let's have a look. Still they are same. We don't have to worry about the map because nothing has changed from there. Apply, close. What I have done is created a generic top level well name. Okay, I right click on it. Now I am telling the system to create me a plan well. Insert plan well, because we are just planning, for example. Plan well, I want to call it, say, NS ERD look-see. Look-see is just early days. Let's say look-see 1. Have a look at this one. Set as principal plan. When you are ready to go drilling with the most final, Rev A, Rev B, Rev C. Before the Revs, you have look-sees, draft. Okay, so you have those. So I'm just playing with it. So I'm calling it look-see, but you can actually call it Rev A. So your look-see is Revs. You can do whatever, it doesn't matter really. But if you work with very big operators, I have worked with very big operators, they have look-sees. They do it in the secret. Nobody knows where the look-sees are. There's no QA/QCs. Then they upgrade it to the Rev A, Rev B, Rev C, Rev B, A, C. All these are taking you to the principal final plan, Rev H or G or whatever. So let's call it Rev A, because that will be that. It means that it's not rough. Okay, it is good. It's not just out of the hat, basically. It is good plan. So we can say Rev a good plan. It's not final, so we cannot click this one. Now, it's coming from this location. Click this button. Why? Because you will be drawing the trajectory. This is telling you the curtain, the vertical section. If you have been involved with any drilling, you know what vertical section is, but some people don't know. A vertical section is actually the view from the side. If you're looking at an ERD well, if you're looking from one angle, it will look like a vertical well. Same well looks like a almost vertical well. But if you see it from the side, properly from the side, at one angle, it will look like a very long well, proper ERD well. So this vertical section, if you get it wrong, then your well will not look right in the section view. When you see it from the plots, it looks really silly. You will be shocked how bad that looks. but you don't need to worry. Just click this button and system will look after itself. Okay, don't worry about it just now. We will come back to this one. What it is saying here is this magnetics is location specific. They are all grayed out. The magnetic information is giving you at the location of your well. This is the magnetic declination, and this is the magnetic dip. This is the total field in Tesla. These are the location-specific magnetic information. Why you ever want to know it? Because this is what is used for calculation for your surveys. Your azimuthal correction takes benefit from it. If you have a wrong location, wrong correction will be applied to your surveys. System does it to show you what it has found out about the location. This is the declination. This is the dip. This is the location. If I change location, it's going to be changing. It's telling you this is what it is applying on these azimuthal calculations. Okay. Now, don't worry about these. These are for creating a sidetrack. And you keep looking on these. If you calculated these values from somewhere, you can have your own. You can have user define this magnetics. And depth reference, if you are switching between various rigs, you may have more than one rig you calculated. You see this one, the top one, we can select that one or that one. The one we created, we want to use that one. You can have several rigs. For example, if you're drilling well and the rig has to go away and come back later. For example, if you in the first round, they want to drill only the top hole. And after 1 year or so, the other rig will come and drill from there, the deeper sections. Then you have so many rigs for the same well. Okay, it's very common actually in the onshore business, onshore drilling. There will be the very cheap onshore rig will come, drill the top holes and leave. Very cheap because the cost is low. All it does is to drill vertical well to X number of feet, let's say 1,000 feet or whatever, and then leave. They are very low cost rigs. Like 4 well, it kiss them, drill them, just the top hole and leave. And then the next rig will come and drill the rest of it, the expensive one. So you save a whole lot of money that way. This is very, very common. It's not a rocket science. Okay, so moving on. We have this survey program. I did not put in anything because we have not got a plan yet. Once you have got a plan, your ERD well is ready, you come here and populate it. Okay. It doesn't have anything selectable. You see, it's got nothing in there. So don't worry about it. Just apply. And the tie on is, of course, the surface. Okay, just apply, close. You see that one? This is my well. Okay, I'm here now. I wanted to actually make it slightly more slick so you can see what we are doing. So for that to work, let's open up a 3D plot. I have dragged it and dropped it. Okay, so I drag it, take it outside so you can see the 3D view if it comes up. Now, let's come back to the instructions. That's the most important part. Let me bring up this instruction sheet. What I will do, I will put in the instructions for you in your chat box. Okay, that would be the right thing to do here. Okay, and I'm pasting it just now. Please pay attention. Okay, this is the instructions. I will follow this. You can also follow it. Just to make it easy, I pasted it so that you don't have to worry about what I said. Did I say 500 or 600? So now you know what we will be following. Okay. Now, look at the instruction. Instructions are, some people get instruction very, very nicely. But before we go there, let's, because we skipped something, let's just do some more work first. Let's install some targets. We need to give it some targets. Okay. For the targets, yeah, we will come to the instruction in just a minute. So come here, right click on it, put in the targets that you will be asked to hit. Plus sign, give it a name, NS, let's say NS, target A. Target A is the first one, for example. We are creating target for our plan. This needs to be done before we actually draw the trajectory. So for TVD, may I give you some targets that you will be using and trying to hit them. Okay, TVD 5405, and you have these map coordinates. People give you the map coordinates. Okay, and this is what we will do here. Northing, suppose you have exact same, okay, which is fine. And here you have slightly different numbers. Okay, I type in 871525.71. Okay, this is what I did. I type in the target in map coordinates. I could also be given map coordinates in geographic global coordinates, latitude, longitude. A lot of time they give you in this. You don't have to worry about it, which one is given to you, but you can choose and type it. In this case, northing is 620.188.3.80152, and grid easting is 871525.71. This is your target A, first target, let's say. This is the TVD, most important to remember this, a TVD. And you said, okay, this is perfect. Now what do I do? Okay, we will have to save it. Click this button, save, on the left there. When I save it, it saved it. Now the name changed. You want this to be a shape of, let's say, rectangle. You want this target to look 200 feet. It's like a square shape, suppose. And it's got a thickness 25 feet up, 25 feet down. When you hit the target, it will be like a slice of bread. That slice of bread has got a 200 feet, let's say, square lengths on the side, and 25 and 50 feet thick, 25 up, 25 down. In the middle, you will hit. And also, I would think it would be nice if that square shaped target is being penetrated vertically, like it will be hitting it just like a bread is vertical. That slice of bread is vertical, and you hit it almost horizontally because you are on ERD wells. Your angle will be 80 whatever degrees, so you will be at high inclination. But let's just come back to it just a bit and be good with it, just to save it as is. And we can say yes, save it again. Now you got a geometry of the target. Let's put another target. You click this one and copy. You click this button, copy the target, call it target B. Okay, just make it easy. Only thing you have to do is to change the numbers, of course. It will copy the shape of your target, by the way. It will copy the shape what you had previously, so you don't have to mess around too much if you don't want to change the shape. That's a little bit shortcut, but be aware of maybe some other target shapes, irregular shapes and things like that. So let's put the TVD for the second one. TVD is 9479. Okay, and then you have tab out. just click the tab button. Everything is fine. You have been given northing as 620.1807.28. Suppose you are given this, and the easting given to you is 876996.07. Okay, and this is what ends up with this. All right, so this is what we have. This is our second target. We created those targets because we wanted to have a goalpost. You are building a trajectory. You need to hit targets. Yes, you need a target before you build it. So I think I missed out a little bit there. But let's just say yes. Now we got everything ready to build the plan. And just one more thing. Let's put in some casings in there. You right click on it, go to the casings, put in the casings. If I may get some casings for us. 2 seconds. Let's just get this. Okay. For the casings, let's put in TVD. Always try to put the TVD 850. And this is the conductor pipe. This is the first casing, and it's 26-inch. The hole you drill with is 36. Okay, spudding. Right now you don't get MD and things like that because you don't have a plan. Your plan is empty. That's why it's not calculating. So why don't we come back to this a little bit later? And it populates by itself because of these. So let's park on this one and come back to this one because it's not, you don't have a plan. Okay, so come back to this one again, a place where we were before. Go to the instructions. The instructions I gave you, you need to use them now. Instructions number 1, drill to 500 feet below mudline. The mudline is at 350. Yes, 350 is your mudline. From rig, RTE, rotary table, to the seabed. What's the distance? That's a mudline, 350. It's asking you to drill 500 feet more below that 350. So 0 to 850, it wants you to just hit it straight. You can see on my right-hand side, things are started to build. And look what you have here. You have your target, the first target, and you also have the second target on the other side. If I may, double click this one and maybe change the color so you can see the colors. The pink one, let's say the first target, and the red one, maybe the red one, or this one is the second target. Okay, have a look at these colors now. You can see these are the targets, and this is your starting the well now. Okay, this is the well you started. And then you say, okay, go to the next instructions because I want to finish this. So let's say from this step, it wants you to build 1.5 degree dogleg, okay, for the azimuth of 90 degree, 90 degree azimuth, and then hold for 2000 feet TVD. So what you will do here, you follow the instruction from here. I want to build 1.5 degree. And once I have built to 10 degrees, okay, it will be built to 10 degrees at 1.5 degree dog leg. Okay, so let's say adjust, click on adjust and dog leg because you want to put a dog leg as a calculation. And then you want to go to the inclination of 10 degrees and you want to go to 90 degree azimuth. Suppose this is what you want to do as per the instructions. And then you say calculate. Okay, So when you calculate it, you can see your shape of your well is changing because you are doing a good job with it. It's trying to go towards the target, the first target, and you have second targets over there. So you are trying to hit them. Now focus on only the first part so that we can see it. Okay, so like this. And then you go about your business to construct the well again, following the instructions. Okay, you want to have a hold of 2000 feet. You would like to go for 2000 feet. Let's just make it like this. And it means that you will hold it same everything, inclination and everything stays the same. You want to hold it for 2000 feet TVD. 2000, calculate. It's growing. This trajectory is being built. And then after that, you get to 2000 feet. Okay. Then you set the casing and everything according to the instruction. Don't have to worry about it casing just now. So you pick up a new section, BHA, and then you build from here 50 degrees with 3-degree dog leg, and just do that one just now. So let's do that. We go to adjust again. We are given the dog leg that we should be using. 3-degree dog leg. I want to build to 50. And suppose the angle is still the same. They would like it to be 90-degree azimuth, same direction. But of course you can change it. You can say, okay, give me 100 azimuth, but you don't have to do it just now for this exercise. You see this one changing because I'm selecting it here. You see the changing the color. I'm on the last one. So I have done some building and then hold the angle. Sorry, the spelling is not good, but you can say hold the angle to TVD of 4900. Click on the last one and say hold it. Keep the same inclination azimuth for the TVD. Click the TVD that you want to hold the TVD. 4900, 4900. So you say yes, there you go. You are heading towards it, yes? You can see it, okay? So you can see you are getting close to that. Okay, you can see it from this direction. Now look at the shape of the target. I would like this target to be a little bit more vertical so I can hit it properly, because the way it is like a slice of bread in the horizontal plane, you want it to be vertical. So you hit it properly. So maybe at this point, yeah, I might want to change the shape of this target. The first target, select the first target, go to the rectangle and make it vertical. Azimuth is going to 90-degree anyway. So let's just do that and press save. When you say save it, I'm just trying to close it. Yeah, there you go. Now you got like a hitting board that you can play. You can hit in the center of it. But anyway, so continue building the plan. You already have drilled. Now at this point, we need to hit the target because we are getting close to the target. We can say let's hit this target. Optimum align, pick up the target A. What dog leg you want it to hit with? Let's say 3 and 3.2. You can have some other, okay? But you can 3 and between 3.5, 3.5 will be okay. And what it is asking you here, where my cursor is, what dog leg, what inclination you want to hit it with? What inclination do you want to hit it with? According to your instructions, you should be at, okay, you should be at 78. Same azimuth, 78. So 78 is your plan of hitting the target, but you can of course change it. It's just a number. You can say, I would like it to, and who will give you this information? Subsurface people, and also some of the learning curves. Some inclinations are bad for you according to the local drilling experience. So it's not coming out of the hat. People know exactly what it should be. So we need to talk to the coordinators and people. So let's just say, yes, what we have done is to select the target to hit and select the inclination to hit with and select the dog legs that we would like to use. Okay. You can see the brown color now. So yellow is nicely hit, and we change the shape of this so it's looking very nice in the middle of it. 25 feet up, 25 feet down. So it is 25 is the thickness of this. So it's actually 100 up, 100 down at this point. But you can also make it fit into any shape. Okay, so this is the way you are looking from downstairs to upstairs. Now you want to go to this target, the yellow, this pink one. Okay, so let's go there soon. Okay, so I will click this one, and now continue the journey. We have hit the first target, set the casing and everything. You're drilling a 12¼ section, which is actually a tangent. Okay, it's a whole section. You don't have to worry about this at all. You have to click this hold. How far you have to go? It's saying that you have to go 8,000 feet TVD. So select the TVD you want to use to hold it. 8,000. And there you go. It is now traveling. You can see here, you are traveling towards the, and you can even drop it and align it. If you are good with it, you can actually align it the way that you want it. Right now it's looking a little bit high. You can even align it here so you don't have to drop angle. Now you have to drop an angle to hit it because you can see you need to drop an angle to hit this target, which is what is required. Sometimes they need to drop it for whatever reasons. You don't change the trajectory because you think is easier. They have their reasons why the instructions are like this. So nothing to worry, just follow the plan. We will go for after the 12¼ 8.5 inch, drop from 78 degrees to 55 and hit the target. Whenever you say hit the target, you have to select the target. So you have to click it here and optimum line, pick up the next target, follow what they wanted to hit with. They want to hit at 55 degrees according to the prescription, and 90 degree, they want to keep the same inclination. So that's, and also the dog legs, 3 and 3. Why 3? Because 3 is a golden dog legs. Sometimes you need more, but 3 is most of the wells can handle it. Wow. Okay, so you have hit the target. You hit the second target, and we can see that we are getting into the target just like that. And it looks fantastic. Only thing is it's got a turn and build and drop, a little bit complexity. And then the last one, keep a hold on it. Give it a hold of 3,000 feet. Give me extra 3,000 feet. That's what it is saying. So you hold it and you say, give me the extra footage of 3,000 feet. Say calculate. Now you got it. This is the TD. This is what you have. The whole, things. You created your first ERD wells. Now, if you go back to your places, you can put your casings in there. Okay. First casing is sitting at, let's say 2000, sorry, 850. Okay, 850. So you just type in 850, use just the TVDs, and then you can type in the rest, the stuff. Let's say the other one is 2000. Okay, something like 2000. It's actually 1989. That's the TVD. And you can say this is the casing, and this is only, it is actually 18.875. This is the casing. And this is the drilling, 22-inch drilling. The instruction I gave you should give you information about how to populate this. The instruction you have is for this, okay? 54075, sorry, just Okay, so you just type in, sorry, this one is not conductor, this is the casing, this is the casing. And you also have to put in 13.625. Okay, name of the casings. And what size did you drill it with? 17.5 or say 16 inch. Let's just 16 inch just to make it simple. Okay, 8,000. That's also a casing. 9.625, 12.25. Okay, and 8.5. I'm just typing in from your instructions. Okay, everything is in your instructions. You can check it out later. Okay. Open hole, you have 6-inch open hole, and it's going to the TD. 28595.26. Suppose this is the TD. This is the TD. You can put the comments. This is the TD, whatever, doesn't matter really. So when I say apply, close, and I can switch on these, I can switch on my casings. I can make it look nicer. Let's say inclination, I want to show inclination. Every 2000 feet, I want to see inclination. And suppose I want to see the casing, the critical points where I'm turning and twisting. And let's see, casings are displayed as well. So let's see. Okay. So you can see the kind of, little bit complicated. So let's turn off just make it 2000. One more zero. That's my fault. So you can see the shape of the well all nicely showing the curves and bends. And you can actually do a lot of stuff in there. Basically you can enable the casing names. You can see where the casings are. Forget about inclinations. And if I may, just the name. Okay, so let's take a look. And you can see this one. So it could be populated with information, with the casing and everything. And you can also do some tricks. You can actually, let's say, you go to the bottom of the well where the targets are, you can go backwards. You can have a look at this one and move this. You can see this one there. Yeah, there is a number changing. You can see, okay. You can see the circle is moving up and down, and now we are at the target. You can see on my left-hand side what dog leg it is passing through and things are changing. Yeah, you can find out. If you have so many wells, if you have a lot of wells, you can actually use this calculation to calculate distances between them, anti-collision and everything. So this is the first trajectory plan as a look-see or the first pass. What to do from this? Yeah, let me show you. If you may open up a well engineering, okay? Open up a well engineering, and then you will open up maybe some case that I have built for it. Okay, suppose that I have the 16-inch RSS PHA. I have created this case. I wanted to evaluate. Now, creating an ERD plan is piece of cake. Okay, you can create it, but now the real ERD planning starts. That real stuff is to actually evaluate all the sections can handle well engineering iterations and the results look okay. Can you drill this section? What do you need to change? For example, this 16-inch section. This 16-inch section will be drilling from 2000 feet to 7165 feet. This 16-inch. Can you drill it? Okay, let's have a look. This is 16-inch, so I'll just put it 16. It's not 17, it's 16. Okay, suppose this is the case. I populated the case. I put in the BHA that I plan to run. I got this mud weight. I got this shape of the well. Let's have a look at the shape of the wells there. Okay, sorry. So it is actually showing you the plots, the shape of your well. You can see the shape of the well. Okay, so let's say dark. You can see the shape of your well, which I have copied and pasted the survey from my plan. This come from copying and pasting things from my plan. Where I place it, I place it here. I copied and pasted from what I just created with you here. 28,000 going all the way to 28,000. It's going 26, but this is what it is. Okay. So I've used my plan trajectory into this one, copied and pasted it. I use my drilling program to populate this. Created my shape of the well. I am coming out of 2,000 feet casing, 18 and 875, and drilling my section. I wanted to know if I can drill it, if my ERD plan is good or not. Okay, engineering parameters from the drilling program. I created it already. Okay, let's calculate. See hydraulics, calculate torque and drag. The goal is to see if there is a problem. Do I need to change my plan? Then you do the iteration again on ERD. So let's have a look at this one. How much flow rate do I need to clean 16-inch section? This is what I have. Okay, and you can see what's going on here. You have, suppose you want to be drilling at 150 ROP. What flow rate do we need to drill this well? Minimum flow rate, 150. That will be the third line. 1, 2, 3. This is the flow rate you require. 1150 will be your flow rate to clean the hole. The highest number you see. This is the highest number, 1150. This is what is required to clean the hole. Can we do it? Let's have a look. With the given rig, what is the standpipe pressure? The third one, yes. That will be somewhere between the third and the fourth. So it will be here. The dotted line will be here. This is your 1150 GPM SP standpipe pressure. The rig can handle it easily, no problem, because most of these rigs, they can handle even more. So you are okay for standpipe pressure limit. Okay. And let's make it 1150. 1150 so we can see the numbers. Maybe calculate again. And just wanted to see it if we can. So now I got 1150 here. You can see that at the TD, this will be your 27, will be your 26, or 27 will be your number. Okay. So you are okay because the rig can handle more than that. No problem. And how about hole cleaning? Can you clean the hole and be successful with moving the cuttings? Let's have a look at angular velocity profile. And look at this one. This is feet per minute. You will be pumping at 1150, which is the third one. Is the third one is more than 150? Is the third one more than 150? 1, 2, 3. No. You cannot clean the hole. The cuttings will not go. 150 is a good number to keep, even more actually. Some people say 200 feet per minute, speed of angular velocity. It's got a low velocity. So 16-inch will have problem with the hole cleaning. This is what you found out. And what you can do about it, actually. There's a lot of things you can do to optimize it. You can optimize the fluid. You can optimize the ROP. We are trying to aim for high ROPs. Okay. But here, ROP doesn't matter anymore because it's just the speed of the fluid. You want that speed to be more than 150 or let's say 200. You don't have that. So what could be the solution for that? And look how difficult this is going to be. Have a look at the survey. At the TD, 70, 100 or so. What inclination you are in? 75 degrees, 78 degrees. Very, very high inclination. So you cannot clean the hole. You need to do something about it. Okay. And that something will be going back to your ERD well and change the shape slightly to improve it on that part, or improvement in the BHA, improvement in the mud system. There are different ways to do it. Whichever is the easiest one, you think? Easiest one is to do engineering. Don't change the trajectory as a first pass. Okay, we'll probably have to stop it because we can talk about these, but now you figure this out, that this is what caused the problems. Not to do this engineering, and just build the trajectory, assume that all these sections will be fine. And we just looked at the first section. We did not look at the rest of the section. During my time when I've been working, these sections, you go through all of them, optimize all of them, and optimize so that they are actually solving all the problems. And not just hydraulics and torque and drag, because of casing wear. They have these surge and swab, torque. Torque is a massive problem. Which section you think will be a killer? The killer will be the long tangent because of the torque. Okay. There could be some more at the bottom. The very bottom sections are the most demanding for technical limits. The rig can provide that much hook load. These are, we have not talked about it just yet, but you start to talk about the top. You go with the easy one, the building to this one. You are here, the first target. This is where you are at the moment, and we are failing it. So maybe we need to go back and improve the ERD trajectory, which is of course iterative process. That's why it takes a lot of time to do it. But this gives you a flavor of how we created it, and we went back to engineering. The real weight is acting on the well engineering. The well engineering is the one that drives it. You find the BHA that fits better, the drill pipe optimization, operating parameters, drilling technology selections, and there's a lot of things that you can actually do. We have not touched on the torque yet. You don't have to worry about the torque because you are so shallow. I don't think torque will be a massive problem. The problem could be the side forces. We can have a look at some of the side forces. We can say, how is the torque holding? Torque 22 kilofoot-pound. That's below the drill pipe. So you should be okay. And somebody might want to say, okay, how about the side forces, the casing wear and things like that? Maybe the casing wear could be something that we can sort out. We can turn off all just a drilling load. This is the drilling load. Okay. If I want to select how much the loading is okay actually. It's not terrible. It's not going to eat up the casing. So you are okay for a lot of things, but you are not okay for cutting transportation. You need a fluid technology, fluid adjustments, or some other stuff that we can probably talk and explore. Okay, I'm going to probably stop it here because I think that could be just the right time.